All right, hi class. So today we're going to talk about titration. What's titration? Titration is a technique to figure out how much acid or base you have. Now, raise your hand. I can't see you if you raise your hand, but raise your hand anyway. Raise your hand if you've ever taken over-the-counter supplement. Vitamin C, vitamin B, zinc. Yeah? Most of you guys probably have, or you know someone who takes these supplements all the time. Now, this one over here is vitamin C supplement, okay? And it says that each tablet has 500 milligrams of vitamin C in it. Now, did you know that vitamin C is ascorbic acid? Have you ever wondered when you're taking these supplements that when it says that each tablet has 500 milligrams of vitamin C in it, that means each tablet has 500 milligrams of ascorbic acid in it because vitamin C is ascorbic acid. Have you ever wondered, am I getting my money worth? Are they exactly 500 milligrams of ascorbic acid, vitamin C in each one? Well, as a chemist, you can actually test that. You can figure out how much vitamin C is in each tablet to make sure you get your money worth. How would you do that? You would use titration, because titration is a technique to figure out how much acid or base you have, and vitamin C is ascorbic acid. That's kind of cool, and that's what we're going to do in lab, to figure out how much ascorbic acid, vitamin C is in each tablet. So let's talk about these titrations. It's a really useful technique. You can figure out how much acid or base you have. Now, when you do titration, usually you have a burette, and hopefully you guys have watched the videos, the lab videos. You have a burette. My drawings are not the best, so use your imagination just a little bit. That's a burette. And then I'm gonna have my acid or base solution down here. So far so good? Okay. Now, let's say here I have hydrochloric acid. Now it's acid-base titration, so what I need over here, I need some sort of base. Let's say I have sodium hydroxide. So I have my acid and I have my base. Now the one other piece of reagent that you need an indicator. I have to add here an indicator. Usually we use phenolphthalein in lab. I'm not going to try to spell it out, but you need an indicator. But what's an indicator? What's an indicator? Indicator changes color. Changes color when there is a pH change. When there is a pH change. So again, remember, indicator changes color when there is a pH change. And when you go over and exactly explain to you how that works. So here's my acid-base titration. I have my acid here, I have my base, and then I have to add an indicator to this acid over here. So far so good? Okay. Now, what's gonna happen? Here's how the experiment is gonna go. I'm gonna add sodium hydroxide to my acid. Nothing happens. I'm gonna add more sodium hydroxide to my acid. Nothing is gonna happen. And at the beginning, HCl is gonna be a clear solution. It's colorless, doesn't have any color, is a clear solution. And then, so my HCl is gonna be a clear solution. And what I'm gonna do, I'm gonna add sodium hydroxide to it. I'm gonna add sodium hydroxide, nothing happens. I'm gonna add sodium hydroxide, nothing happens. I'm gonna add sodium hydroxide, nothing happens. It could get boring sometimes, and sometimes when I'm teaching Chem 30A lab, people they're on Tinder as they're doing this. Don't do that, don't be on social media, okay? If it gets boring, just stay with it, okay? I had to put on a board, no Tindering while titrating, because people were bored. Could be a little boring, but hey, stick with it. You're gonna keep adding NaOH, nothing happens, nothing happens, nothing happens, and then bam, the clear is gonna turn into pink. And you have to make sure the pink stays. Sometimes when it turns into pink, if you shake it around, it goes away. That means you're close, but not quite there. So clear is going to turn into pink. And then you're done with your titration. Okay, so let's go over this again. You're going to have my burette. I want to have my solution here. I have my acid here, my base here. It could be the other way around. I have an indicator. Indicator really, really matters because otherwise there's no color change. Okay, I want to add an AOH. I'm going to keep adding. This is clear at the beginning. I want to keep adding. I'm going to keep adding. I'm going to keep adding. And then bam, at some point, and don't give up. Sometimes it takes a little while. It's going to turn pink. And then you are done with your titration. Now the question is, what does the pink mean? What does the pink color mean? So let's go over. Again, stay with it. Pay attention to this titration. Don't be on your phone as you do the titration. Because sometimes you add one more drop and then bam, you see the pink color. Alright, so the question is, what does the pink mean? So when you see the pink, you're done with the titration, but what does it mean? Let's go over what titration means. I'm going to simplify it for you. Sometimes it helps to simplify things, so I want to make sure you really understand what that means. Okay, up here, I said I'm going to have NaOH, right? And down here, I'm going to have hydrochloric acid. So far, so good. Okay. Now, NaOH, we've done this before. When you have NaOH in water, NaOH breaks up in water into Na plus and OH minus. And remember, what makes NaOH to be a base? Sodium hydroxide is a base because of OH minus. OH minus is what makes something to act like a base. So far, so good. So what makes sodium hydroxide to be the base is OH minus. So what I have here, I have a bunch of OH minuses because that's what makes something to be a base. Now, down here I have hydrochloric acid. Hydrochloric acid in water would break up into H plus and Cl minus. What makes hydrochloric acid to be an acid? What makes anything to be an acid? This H plus. H plus is what makes something to be an acid. So what I have here, I have these H pluses. So far so good? Okay. Now, remember, you have no idea how many acid you have. Titration is a way to figure out how much acid or base you have. I have no idea how much acid I have in here. Okay? I'm going to start my titration. I'm going to add a drop of sodium hydroxide. The OH is going to go down here and it's going to react with H plus. If OH minus reacts with H plus, what do you get? You notice OH minus plus H plus, what do you get? You get water. You get H2O. So it's going to neutralize it out. The other one, the OH is going to come down here. It's going to react with H plus, neutralize it out. Another OH is going to come down here. It's going to react with H plus, neutralize it out. I'm going to add one more drop of OH. It's going to come down here. And then the OH is going to hang out here, but there is no more H plus to react with to form a water and to neutralize it out. So then what happens? That's when it's going to turn pink. I'm going to explain this again. So what makes something to be a base are the OH minuses. What makes something to be an acid are the H pluses. I'm going to add sodium hydroxide to my solution. OH is going to react with H plus, neutralize it out. The other OH, H plus, neutralize it out. And it just keeps doing that until there is no more H plus left. When the OH comes down here, it has no H plus to neutralize it out. Now the solution is basic. And the indicator changes color when there is a pH change. Now it's going to turn pink. And sometimes when you're doing a titration, you see a pink, but when you shake it around, it goes away. That means like you're almost getting there. The OH had to kind of look around for the H plus, but it finds it, and then the pink goes away. Now this is when it turns pink. Okay. Now here's the thing. Remember what we talked about? You did not know how many acid you have. How many OH did you add and then it turned pink? You added 3 OH and then when you add 1 more OH, it turned pink. So I added 3 OH and then when I added the OH, it turned pink. So I added 3 OH before it turned pink. That means I had 3H plus over here. I added 3 OH and then it turned pink for the fourth one. That means I had 3H plus down here. So you can figure out how much acid you have down here based on how much of the base you added. You guys follow that hopefully? Okay, nice job. So this is kind of cool. Now, little fun fact. So I had a gender revealing party last year and I used the titration to reveal that I was having a girl. So I added 2 clear solutions. Sodium hydroxide is clear, hydrochloric acid is clear. I added together and I had a phenolphthalein in there and it turned pink. And then that's how I showed my family with science that I was having a girl. I thought it was kind of cool. A little bit nerdy, but cool. So far so good. So that is the concept behind this. Now what we're going to do, we are going to do some practice problems, okay? We are going to do some practice problems. Let's do some practice problems. Here is our first practice problem. Let's see, which one do I want the first practice problem to be? Let's do this one. So I want to show you how to do practice problem now that you know the concept. 20.0 ml of nitric acid, HNO3, is titrated with 0.10 molar sodium hydroxide after adding 70.0 ml NaOH, it turned pink. What is the molarity of nitric acid? Okay, so here is our problem. Now, every time you have a titration problem, what I want you to do, I actually want you to draw it out. So every time you have a titration problem, I want you to draw it out. Okay? So every time you have a titration problem, I want you to draw it out. So what do I have here? Here I have NaOH. And what is the concentration of my NaOH? Is 0.10 molar. Down here, I have nitric acid, and it's 20 ml. And then what I said is that I'm going to keep adding, I'm going to keep adding, I'm going to keep adding. After I added, how much is that? 70 ml, 70.0 ml, then what's going to happen is going to turn pink. It's going to turn pink after I added 70 ml. Now the question is, what is the molarity of nitric acid? So hopefully in lecture, you guys are already gone over molarity, which is moles per liter, and dilution. Now let's do this one together. Again, do this every time. It helps you to visualize what's going on. I have my base over there, I have my acid over here, I keep adding, 70 ml I added, it turned pink. But anyway, you stop when it turned pink and it stays pink. Now the question is, what was the molarity of this solution? Well, how much acid did I have in there? Now remember, molarity is moles per liter. What's molarity? Moles per liter. I want you to repeat that after me. Molarity is moles per liter. Molarity is moles per liter. I know I can't see you, but I still want you to do it. Molarity is moles per liter. Okay. I have the molarity of NaOH. And I know how much NaOH I added. So can I figure out the moles of NaOH? Yes, you can. The molarity of NaOH is 0.10 molar. I don't know how many moles I have, but how much NaOH did I add? 70 ml divided by 1,000 because it has to be liter. It has to be liter, so I have to divide it by 1,000, so I get 0.0700 liter. Okay? Molarity is moles per liter. So what I had milliliters, I had to convert it to liters. We're good? I had the molarity, I had the volume, I want to solve for X. And X is going to be my moles of NaOH. So what I get is 0.0070 moles of NaOH. I want to go over this with you one more time. So molarity is moles per liter. I have the molarity of NaOH. I know I added 70 ml. Divide that by 1,000, it will be 0.07 liters. Now the question is, if this is a molarity and I added this much, how many moles was that in that 70 ml? So I can just plug it in. The X is 0.0070 moles of NaOH. I've added. Now remember the practice problem that I showed you before this. We added 3 sodium hydroxide and then it turned pink, which means how much acid did we have here? Which means we had 3 acid in the solution. Now, I added 0.0070 moles of NaOH and then it turned pink. So how much nitric acid did I have in here? The same number, right? Think about, I can't go back now, I erased it, but go back to the problem I did. I had 3 H plus here, I added 3 OH and it turned pink. Because I added 3 OH and it turned pink, then I knew I had 3 H plus. This is exactly the same thing. So what I did, I added 0.0070, then it turned pink. So how much of the acid did I have? That means I had 0.0070 moles of the acid. Follow me so far? Okay, beautiful. Nice job. Now, what does the question ask me for? The question asks me for molarity of nitric acid. One more time. What is molarity? Molarity is moles per liter. Do you have the moles of nitric acid? You do. We figured it out. That was 0.0070 moles of nitric acid. Okay? Now, do I have the volume of nitric acid? You had 20 ml of nitric acid. Now, again, remember, for molarity is moles per liter. So I divide that by 1,000, I get 0.020 liter. So far, so good? Okay. So if I divide these two together, again, I'm limited to 2 sig fig. Don't forget the sig fig. I'm limited to 2 sig fig. So my final answer is going to be 0.35 molar. 0.35 molar. So far, so good? Okay. Really, really nice job so far. You guys got this down. Again, always set it up and then do this. Set it up and then go for it. Alright, ready for next practice problem? Let's do this. Again, titration is a way to figure out how much acid or base you have. Set this up every time you do a titration problem, and every time you have to figure out how much of the base or the acid you add before you turn pink, and then you can figure out the other variable. Okay. Here's our next practice problem. You ready? 5.00 ml of vinegar is titrated with 0.200 molar sodium hydroxide, 21.57 ml of sodium hydroxide was needed to reach the endpoint. What is the percentage of acetic acid in this vinegar sample? Okay, and for the percentage, you want a percentage of mass over volume. Now, we're going to do a lab on this, so I want to make sure we really understand this. So what I have, again, this is the same thing as before, okay? This is the same thing as before. What I'm going to do, I'm going to draw a little setup, okay? I'm going to draw a little setup. What I have here, I have a 5 ml of vinegar sample. What I have here, I have an NaOH. This 0.200 molar is the concentration. What I'm going to add, I'm going to add 21.57 ml, and then you reach the end point. What does the end point mean? That's when it turns pink. They call it the end point. To be like fancier, it sounds a little bit better than just turn pink. So you reach the end point means what? Means it turned pink. Okay. So now the question is, how much acetic acid did I have in here? So vinegar. You've had vinegar before, salad dressing, right? Vinegar has like a sour taste to it, doesn't it? The sour taste, the reason is because vinegar is made from acetic acid, and acid has a sour taste to it. So vinegar is made from acetic acid. Think about that next time you're putting vinegar on your salad. So I have a 5 ml of vinegar sample. I want to basically figure out how much of this sample, how much of that there is acetic acid in there. So I have a 5 ml vinegar sample. I want to figure out what is the percentage of acetic acid in this sample, because vinegar is water and acetic acid. So vinegar is water and acetic acid. I want to figure out how much of it is acetic acid. You following me so far? Okay, beautiful. So again, let's go over this one more time to make sure you really understand this. Here's my setup. I have sodium hydroxide, 0.2 molar. I did a titration after 21.57 ml of sodium hydroxide. Then it turned pink. It reached the end point. And I want to figure out, so here's my vinegar sample, right? And remember, vinegar has acetic acid and water in there. So I want to figure out how much acetic acid was in 5 ml solution of vinegar, and percentage is mass over volume. How much of this volume is the vinegar? Okay. Now remember, any titration problem, I want you to do this. What's the first thing you're going to do? You're probably yelling at me right now that of course we're going to do molarity is moles per liter. Molarity is moles per liter. Very good so far. Okay. Now, so molarity is moles per liter. Do you have the molarity of NaOH? You do. Do you have the volume that you added? You do. Does that mean that you can figure out the moles? Yes, you can. So, what is the molarity of NaOH here? is 0.200. How much of it did you add? 21.57 ml. But you have to convert it to liters, right? Divided by 1,000, what do you get? 0.02175. And then this is going to be my x. You follow me so far? Okay, do you have your calculator out? If you have your calculator out, what I want you to do this math, and then let's say to get up. This is 5.7. I don't know why I switched the places. Okay, calculator's out. Calculate x for me. I want to make sure you get your math right, and I'll do it with you. So take your calculator out. Make sure you get the math right. Okay, what did you guys get? Hopefully what you got was 0.004314. Let's go over the algebra to make sure we're on the same page. When is equal, you have to cross multiply, right? When is equal, you have to cross multiply. So 0.200 times 0.02157 is going to give me the x. So I have to cross multiply. You cross multiply when there's an equal sign here. Okay. So what this is the moles of sodium hydroxide. This is the moles of sodium hydroxide. So I added 0.004314 moles of sodium hydroxide, and then it turned pink. So what does that mean about acetic acid? How much acetic acid did I have in there? The same amount. Good job. So what that means is I had 0.004314 moles of the acetic acid. Because remember, it's an acid-based titration. I'm trying to figure out how much acetic acid I have in this 5 ml vinegar solution. We're good? Okay. Again, the same before. You add the base reacts with the acid, it forms water. When all the acid is gone, that's when it turns pink. So I added 0.004314 moles of NaOH, and then it turned pink. That means I had that many numbers of the acid. Beautiful. Now, the last thing that we have to do, so you guys are good with this part? Okay. What does this question ask us for? What this question asks us for is percentage of acetic acid in this solution. Okay? So make sure you copy this down. Percentage. And we've talked about this in lecture before. What this means is, so the percentage of M over V. Okay? That means the grams of acetic acid over the milliliters of the vinegar solution times 100%. I want to figure out in 5 ml of the vinegar solution how much of it is acetic acid. Because the vinegar that you put on your salad dressing is not just acetic acid, it has water and other stuff in it too. So you want to figure out how much of it is acetic acid. What's the percentage of that? So far so good? Okay. Now, we don't have the grams of acetic acid, but what do we have? We have the moles of acetic acid. I know I just erased it, but you have it in your notebook. 0.00414 is my moles of acetic acid. How do I convert moles to gram? You already know that. How do I convert moles to gram? Molecular weight. 1 mole of acetic acid, if you look it up, is 60.1 gram. So if you look it up, it's 60.1 gram. So the moles cancel out, okay? You ready? You have a calculator out? 60.1. When you do that, what do you get? What you end up getting is 0.2592 grams of acetic acid. That's grams of acetic acid. You still following me? Okay. So I had the moles of the acid times molecular weight. I get the grams of acetic acid. So I'm going to come over here. The grams of acetic acid, I know what to put over there. What do I put over there? That number is right here, is 0.2592. Okay. Now, how much vinegar did I have? I had a 5 ml vinegar sample. So over here, what am I going to write down? I'm going to write down 5.00 ml. 4 sig fig, 3 sig fig. My final answer should have how many sig fig? 3 sig fig. Good job. Okay? So, if I divide that by 5.00, what do I get? And you have to times it by 100. 3 sig fig, what do you get? You get 5.18%. 5.18%. So there's about 5% acetic acid in vinegar. Now I have a challenge for you. As soon as you're done with my video, go to your fridge. If you have vinegar in your fridge, take out the vinegar and read the label. And on the label, I promise we will tell you the percentage of vinegar, the percentage of acetic acid in your vinegar. And I'm willing to bet, I should probably bet points, right? That is gonna say is 5%. Because most vinegar solution have 5% acetic acid. And now you know what that means. Okay, good job, nice job. Then go look at the sample of vinegar to see how much acetic acid we have in the vinegar.